Hello, my name is Sadeh and I work at Zalando SC. Today's session is about self-healing queries in Presto. We'll touch upon a prototype where we're taking AI assistance in terms of troubleshooting and having features like Auto-Retry in Presto workloads. So, hope everyone is excited in today's PrestoCon day. Just a brief disclaimer that the views, opinions, and ideas expressed in this presentation are solely my own and do not reflect the views, possessions, or policies of my employer, any organization with which I am currently affiliated or was. This content is presented in a personal capacity towards open source and should not be interpreted as representing the stance or perspective of my current or past employers. So let's talk about the problem with Presto failures. So, as we know, Presto is a very powerful and helpful engine, but we all face failures in terms of errors, in terms of optimizations, in terms of retries. And these can be painful, and sometimes I think we have taken it in a very good stride to be resilient and try them ourselves, go through documentation, learn through the process. And some of the common causes could not only be syntactical, schema based, or errors where the references are not correct, uh, based on how your data is structured, and but also on your cluster sizing and your memory exhaustion, etc. So manual troubleshooting slows down engineering velocity. The time spent in terms of operationalization, which we have uh, over the time become accommodated to, leads to some of these manual and uh, often repeated tasks, which could be better utilized or spent in uh, solving business problems rather than in operational efficiency, uh, improving the operational aspects of it as we run these queries. And many times rerunning these queries without fixing the root cause or understanding it rather is kind of resources spent in a wasteful or not in such a productive manner. So I think these are some of the topics which we'll touch base upon in today's session. Thinking about the current paradigms in generative AI or the idea of agentic AI and large language models, thinking of that aspect and bringing it and integrating it into the database of Presto system brings us to the topic of what if Presto could think for itself and fix some of these issues for us. So the question becomes, can Presto become self-healing in terms of its interpretation, in terms of running them itself and solving us without being taking too much time into it? Because as we will talk about, some of these processes could be quite lengthy, quite iterative. So what is the right trade-off or the right balance for us? So here is where will be introduced to the idea of using AI and automation, because AI can give you a result, but we have to take the feedback, understand it, and kind of see if it can be further improved. This is where the tooling layer of agents and running it across systems helps, and automation to reduce the manual toil which we have been used to. So we'll also go through some of the coding which helps us to develop this prototype. This is just a very short brief as to what some of these inputs are which we think about, like the query logs. What are the queries which you have been executing? They explain plans, the error messages which you see when you run a particular query, and the session properties and conflicts of your system, and as such, which help you improve your queries. Those are very relevant because I think if you think about those are the um, contextual elements which we ourselves take when we think about them in our minds as to what could be the potential issues given these circumstances or these query logs or these error messages and the understanding we have of the Presto system and some of the information from the documentation, including the context of the schemas. And if you think about this, could be sometimes uh, too much cognitively for us to remember. And so, therefore, we always take stepwise information. But if we think of this information being fed into a large language model or a generative AI and let it figure out some of these very incremental steps, and also at some steps taking multiple steps together and giving a solution to us, this becomes a rather helpful layer or assistant for us. Now, here is where we'll talk about some of the classic RAG pattern. And I understand at this moment, RAG is quite popular in terms of how large language models process your data and give you uh, relevant information back. But just for everyone's information, so that we have a very good uh, foundation here before proceeding. So if you see, we have a user query and we have a bunch of documents because I think one of the side effects of large language models is they are trained on a huge amount of data which could be biased, and when you try to query something, they rather seem act intelligent, but what they are doing is they are generating a sequence of probabilistic sequence of words based on the probability of the occurrence of it in terms of its knowledge base on which it has been trained. So if you think about it, it's not doing something very intelligent. It's kind of processing it from its whole knowledge base, and sometimes it could hallucinate, like give an answer in a way which seems pretty valid, but is factually or in relevancy terms could be inaccurate or totally incorrect. So this is where to ground it better, uh, embeddings help. So embeddings are the vector mathematical representations of sentences or words in a particular dimension. You can think about a 3 dimension, but it could be kind of thousands of dimensions too. And that's where the sentence or the word is represented in that dimensional aspect. When you think and correlate, very similar correlated words or sentences lie in a very closer represented area of the dimension. So when you do a similarity, a cosine similarity, or a Euclidean distance similarity, you find very similar elements together. So that is where the embedding model helps to convert your query to the embeddings format and then match relevant documents in a vector store. Here we are taking just an open search for an example here, but you could think very similarly about other vector stores where you compare using these cosine or Euclidean similarity and you get the matched documents. So the final mm, step now is that you feed the query along with the documents. So now you're asking the large language model, okay, these is the context to which you need to relate to and answer the query. So now it gives you the response back, but more in a natural, human friendly language. So this is what RAG is all about. Now, how do we build this AI assistance ecosystem? There are two approaches at this point which we can think about. The very first is thinking about an external chatter ecosystem. So you have your Presto system. But let's say we build another, for example, a mobile or a web interface where we have a chatbot, where we question it, and this has no relevance to your Presto system. It's completely independent, where you can feed some information to a large language model and get the response back. We'll touch base upon what are some of the pros and cons of it in the next few slides. The next approach is we can similarly build a extended ecosystem by adding a connector. This connector can connect with a large language model because it's an integration of two systems, and it grounds the large language more better, I think, when you think about getting those contextual information from a Presto system because it integrates with it. So we'll further discuss both of these two aspects. The very first from the right, the external chat ecosystem. So some of the pros of it is it's quite quick and easy setup. We don't need to think too much about the Presto ecosystem, and it's simple to set up. While the cons could be it doesn't have any context of your system, so you have to run your query, explain, and gather some of those contextual information, schema, the configuration, and pass it as a prompt uh, to the large language model. So the different ecosystem, and you're building another layer on top. So in a very simple manner, this is what it looks like. You have a query and you have a prompt. The prompt could be very complex here because you have to send your documentation. But the large language model might not have those information about Presto, how it works, what it explain means. So all this documentation could be fed into the prompt, and it also doesn't have any idea about your configuration, about your schemas, and what your configuration actually means in the context of a Presto system. So these are all the information if you have to pass to the large language model, and then you get a response back. But as said below, another con is that if you see one of the importance is a prompt, you have to ask it to act in a particular manner as to what its role is, and give all this information to it. Maybe also give it some examples so that it can respond in a particular manner. But the prompt window could be very huge, and so your large language model only does have a particular context window size to it. So that is another limitation of it, and your response could be as good as your prompt, and it may not be the perfect result you might be looking for. The second approach is the connector ecosystem. So some of the pros to be considered here is it's a very similar environment. You're already uh, uh, used to learn about the Presto ecosystem, your build connectors. It adds more context, actually context information, without giving it those externally. So the system itself could fetch the information by running explain queries on top of the queries, and also some of the contextual information like the config parameters could be sent to it, and you're actually having a real execution details instead of having a simulation or emulated behavior of it. Uh, Two cons of it is that it could be complex, given that you need to think about what you're expecting or trying to build out of the system. It could be as simple or it could be more complex based on some of the points which we'll discuss later. The second point is the integration needed. Well, you'll need some integration along with connect to your large language model and define the sequence of events which need to happen, which we'll talk about. So the question arises, where does Presto fit here? So Presto as an engine, if you think about it, acts as a core system where the large language model could interface with it, run a few queries to it, and gather the result back, and then process it, run further queries. So it could be a reiteration, it could be as simple as just feeding it the first query, getting the result back, presenting it in a different manner, uh, more in natural language, etc., and giving the response back to our users. This is a very simple connector architecture which everyone understands. So to just repeat myself here, you have the client which sends or the user who executes a query and sends it to the coordinator. The coordinator passes, analyzes it, plans it, and schedules it based on the information it gets from the different metadata APIs and the data location of the connectors, based on which it then executes it through the workers, which are present at the very bottom, two workers, to execute them across the connectors and using the catalogs. Now, if you think about this system, this is how it operates currently. Now, how do we bring about some of these concepts which we talked about from the large language model um, and connect those information together? It wouldn't be as simple as just connect the large language model because it's always an iteration step, and the large language model needs some information, so where does it get it from? This is where we extend the connector architecture. So now if you see here, we have, when the query is executed, we build a custom connector here, which takes as inputs two columns which are defined for it, which the action, it could be an explain or a query. So if you wanted to run an explain on it to understand it, so yeah, extending the ecosystem through a single interface, or you want to query, run the query for it, and you can also pass it some schema information. This schema could, I think it's a extended information on extra effort overhead, which we can remove here because I think the system can itself run some of these queries and get the schema information as to what are available. But also we could present it if we have an idea that this is the overall schema for this application. So this is also something which we can integrate into the connector layer. Now, once you have this information, you can run it across the connector, can execute a client request or Presto system, and fetch some of this information back. So this is the basic task of this connector, this custom connector we are looking at. Now, where does the large language model come in? So if you see the sequence of activity, the queries first, it's using the custom connector here. Now it could be a simple query with a schema layer. The connector then executes and runs it to the client interface or use a custom client API. And this is then, let's say it needs to execute within MySQL connector. So this is where now it executes the worker result with the data stream. It fetches a result from the MySQL, and then once it has received back the response, it can give it back to OpenAI or any large language model of your choice. So now there could be a prompt here which say this is the query, this is the result, and it could get back the result in a more user-friendly the schema has been defined. And this is now fed back to the user so that they can see it. So now we understand if we want further information done, explain here or reiterate. Let's say the query actually gave us an error back. So this is where through OpenAI we can decide to fix the query because now it is understanding of your schema. It has a context of the error which is seen. So it can re-execute the query. And sometimes you can think about, since it's a large language model, it has the capability to make some of these mistakes. But we could further give it some few short examples as to what it could look like, the exact syntax of these. And many of these large language models are more SQL oriented, so I think those could be more better for these situations. So once you execute them, you send them back, and you could also have a threshold as to how many retries you wanted errors. And all of these could be also collected back so that you're giving this as a very contextual information as to how the assistant arrived at the final response, but also how it improved because it gives you feedback as to how your connector is performing so that you can improve it. Because observability is very important when you're connecting different systems as to how it's performing, for your application, because every application has its own context. The next layer as to how do we incrementally improve this. So if you see about many times you have business or product who want to understand and run analytic queries on top. But they don't want to understand how a SQL looks like. They want a very user-friendly interface, like a natural language. So the connector here is a bit changed. If you see the action, instead of taking the query explain, it takes a problem statement. It could be a very uh, simple query like what's the maximum number of the revenue across this year. This is a very general query. It doesn't say which table you need to go to, which schemas you need to use. It basically gives the information. So this information along with the schema which the connector could itself fetch it is fed to the large language model. So large language model now knows, okay, there's a schema. I just need to interpret the schema in terms of a SQL using the columns and the tables which are present, represented in terms of weight, right Presto query. So there's a very helpful layer where it converts internally, but it doesn't have to be understood. This abstraction doesn't need to be understood by the business. They want the result, and this query is ultimately fed to the step 4 to the client, the Presto engine. So you get the response back. So there is some iteration here. If you see, you're touching the MySQL catalog and you're getting back the response to the connector, and now this response is fed to the client, which is the final step in step 6. So if you saw the iteration from step 1 to 2, 3, and finally the response, the query being executed, there could be an error in the query. So this is where the feedback layer helps in. And sometimes there are more advanced aspects to it, like using agentic AI, where you have different agents responsible for it. But this is just a very starting layer to think about bringing AI assistance to help and bridge uh, the skill levels of different personas and strive towards a universal uh, Presto layer, which gives you the result irrespective of the language, whether SQL or natural language which you're using. There's some of this sample code which helps for the connector layer. Like this is how you're requesting to OpenAI with the particular role and what the user query you wanted to address. And in very raw Java, but you can also use some of these Lang 4j, LangChain 4j, and Spring AI, which is generally available, I think, at this moment, giving you more abstractions to use any large language model. And this we're heading the RESTful API endpoint to get the response back from OpenAI. And these are some of these steps in terms of executing the explain query and getting the explain result and feeding it to the OpenAI, and also running an optimization step where you can think about whether you got an optimization feedback. If yes, there is an error here. So how do you do an if else? So it helps you to think about some of these steps. And this is some of the abstracted layers like running the explain query, executing in Presto to give you more fine details and control. So what's next? If you think about this, uh, you can have certain uh, fine-grained layers like to expand upon the error type coverage, and this can also be integrated into the Presto coordinator, but I think that's more of a different level of skill sets into the code language, which could be explored. But if you think about this, really brings about from a connected perspective, extending the system without affecting the core of it. And The next point is we need also to think about the human in the loop. So this is completely automated, but a feedback can also be taken by having another column by adding a different hint to it, like to use it, and also have a memory layer. Because if we run a query again to query it something, it may not remember the previous conversations or the queries we ran for it. So there are different layers to it when we think about it incrementally. To take human in the loop feedback. And when you try these aspects, you have to see the performance or observability to see whether simple RAG or a large language model or to bring in an agentic AI layer here to improve it. Really, there are certain side effects here since you'll have some latency in terms of running the query, getting the feedback, having some parallelization around these. These are some of the aspects which you can think about. Now that we have considered some of these foundational elements in the architecture, we can think retrospectively as to how this helps and why this matters. There's less toil for engineers, there's faster root cause detection, and there's a higher or improved success rate for complex workloads. Instead of engineers are starting with Presto, thinking about the complex system, improving them, it always adds in the learning, but there's always a trade-off as to adding business value versus the time spent here. There's always, I think, the feedback which has been taken. Let's say, if the system goes around 3 iterations to find the solution, I think if this solution or the steps are represented back into 3 rows when the result, giving the final and the iterative steps, that also helps in a very quick learning in terms of the AI assistant helping us if you go to Google and getting the answers, trying it, but in a more process oriented way and see the results. Well, if this is built as a platform for a team, it really helps the whole organization. And if you think about how we incrementally started, builds towards a vision for a smarter, more resilient Presto system, adapting to different personas through a single interface. There's a very brief introduction about myself uh, and about the books which I've written. One of the books which is coming in the generative AI driven application development with Java in the summer of 2025. And due to courtesy of April, there's also a limited time 20% discount code on these books, especially the first two, with a PrestoCon 20 for all the attendees of today's conference. And if you guys want to connect with me, those are links which you can access and connect with me if you have any questions. I hope this session was helpful to everyone in terms of understanding the ecosystem and thinking about adaptive layers so they connect the ecosystem. Thank you so much.